right, everybody. How are we doing? We got pretty good. All right. Let's see. All right, guys. Welcome to our bi-weekly noise reduction active. Yeah, sorry. Yep. I didn't really test that. I could try to noise suppression off. Maybe I turned it off. Maybe I'll try another round at the end. See if it comes in a little bit better. All right. So this last couple of weeks, I've mainly been working on bug fixes. So I've been kind of straddling. We've got biological ecosystems futures, and then we've got Arun and Aeonwise doing testnet, and we got Kendall on that too. So I've been kind of straddling one for each. So pretty much I found a pretty big bug that was causing a lot of issues with some of the indexing systems. So I got that pretty well sorted now. It was just a caching issue that we had initially, and then basically testnet, we had some issues. I think we had like a 600,000 transaction queue that needed to process, and that broke one thing. So we've been finding a few different bugs, some stress related, some not. Some were optimization related, like the caching bug that I found. That was an optimization related bug. So everything's doing pretty good. I mean, I've been pretty happy with it. We've got just a couple more things. I just wrapped up the precision T and getting that piped into the JSON class, right? All of that's pretty much put together now. And then, yeah, just the last few final bug fixes. So I'd suspect probably by the end of the month I'll be having it like moving on to 5.2. While the rest of the guys wrap up the 5.1 interface and testing and stuff like that. That's pretty much where I'm at right now. Is I'm starting some of the design phases of 5.2, which I wanted to touch on for this specific instance, so that you guys can kind of understand and see what's in the future, what's coming out, what to expect. So the 5.2 update is kind of like a post 5.1 update that we kind of broke it up into two updates. If you guys remember, we did a vote. And we realized that we wanted to have a little bit, we didn't want to continue waiting for 5.1, and then keep adding more and more features. So it's scope creep, right? So as a community, we decided, okay, we're going to cut the features off at where 5.1 is now and move on to the 5.2. I forgot one thing to mention on 5.1. I don't think I've mentioned this before. I've added variables into the core. So what that means, I guess you could consider them functions. So if you look at a register, if any of you developers see it, you'll see the register is just or the register created or modified timestamps are just a big long, I guess it's called a Unix timestamp. What it means is the number of seconds since 1970, January 1st, 1970. So this Unix timestamp needs, you can't just go type in like January 5th, 2022. That won't work the way that we anticipate it. What we have to do is we have to develop. All right. What we have to do is you have to convert that into an actual Unix timestamp. So one of the things that I did to develop a little bit more user friendliness is I created a date function. So you can actually type in a regular date and then it'll convert that into a Unix timestamp. We have other aspects too, such as I think there's a resolve one and there's a username one and a genesis one. So it's kind of like a function within the function, and that allows you, like if you're doing like a date query, let's say you want to do like register list, accounts, for instance. And you want to say, that are modified within the last day, then you just run a modified timestamp. And based on that, you can use the date variable. So as a developer, you don't have to go through the cumbersome converting of all these different things. So that's just one more thing that we've added for user friendliness. It makes it really easy for people to be able to develop on it. You don't have to worry about, converting all of these things in your app. One of the design features that I've really wanted 5.1 to support is just to be really capable, but really simple to use, right? And make it, so that, lower the barrier of entry, I guess you could say, for the technical requirements in order to develop on it. So I'm going to actually mute everyone here. Let's see. I wonder if there is a mute. New participants are muted. I'll unmute everybody in a moment. So The variable system basically makes it really, really simple for you as a developer to just, hey, I can modify this, I can put in these date variables, and that's plugged into the whole query system. And then another really cool feature that I added is the ability to actually call objects from the entire scope. So if you guys remember, I was talking about how I've templated everything and made it so that it's this, basically you only have to inherit a few functions and just model a new object. Like for instance, the supply chain API is only 100 lines of code now because it's all running through these actual templates. And so each of these APIs essentially is just like running a series of templates. Sometimes you'll have a custom command, but you model this object with it's a function, right? And it just evaluates to true or false to just filter the object. And so you can basically say, okay, I want to create a custom title object, for instance, and you're going to have a VIN number, you're going to have a time and a date, so on and so forth. That can be basically developed into the API, so you can design your own custom objects. And that's, if you guys remember the dynamic object modeling, that's part of that. But right now it's inputted into the API, hard-coded, but on a 5.2 post release, I'm going to make it a dynamic indexing. So you'll be able to actually invoke and call that specific object. But what I was getting to earlier on the 5.1 is you can actually access any of these in the register API. There's the register and the ledger API. Those are the two global APIs. And that's what allows you to view, let's say, the global scope of objects that are independent of your specific SIG chain. It's doing a register list and it checks. It allows you to query on the entire global scope. So if you want to look up all of the accounts, you don't actually have to input anything into the register API anymore as a developer. You can just call the finance API as account. So you could do like register /list/finance:account, and that will extract that object out of the finance API. So essentially every single object that exists in all of the API functions is available in the register API. So that was a really cool feature too, because now we had this kind of was bred from a feature request from interactions where they needed access to the invoices data, because since I added the dynamic indexing services, it's all local scope now. So you're not actually iterating and searching someone's tick chain. You're actually just reading your own local indexes, but it only builds local indexes for that specific user account, right? So that basically allows you to say, register list invoices : paid, or invoices : unconfirmed, or whatever, and that'll pull those specific objects from that that API. So that was a really cool feature that really added a lot, and that's pretty much the last couple little features, I guess you could say. I wouldn't really call them like new features. They were just kind of baseline requirements to meet the level of functionality we had before with some of the rearranging and all of that. So that's pretty much 5.1. Like I said, my rough timeline is I'll most likely be done with the bug fixes within the next couple weeks. By the end of the month, I'll be turning that over to the wallet team. They're already in parallel to all of this developing their wallet stuff, right? And they're shooting me questions. So we've had a pretty decent open communication related to that. So that's moving along very well. I've been really happy with the results. Just a few things around the edges. So I'm getting prepared mentally, at least, to move into the 5.2 territory. So this is where we start getting into the peer-to-peer, what would be the peer-to-peer messenger API, the crypto API, and the decentralized login API. So I wanted to kind of briefly touch on these and explain what they're there to function for, right? So the peer-to-peer messenger API, that's a really, really important one, because what it essentially does is it's an API framework to develop peer-to-peer communication systems. And it doesn't require any central servers. It runs on a network, and it also allows you to open these connections to usernames or Genesis IDs. So you no longer have this issue with discovering where someone's IP is. And usually the way encrypted messengers work is it's a client server infrastructure. And there's been a couple peer-to-peer chat messengers I've seen, but they're bad because with peer-to-peer you're connecting person to person, right? So if you want to send a message, they have to be online, and you don't really have a message retention system. And so the centralized messaging protocols tend to function a little bit better. There's not really been many peer-to-peer. Now, one of the really important advantages of a peer-to-peer messaging is you don't have any central servers. You don't have any central authorities. You don't have anyone holding all of these messages to track who's sending to who, right? You essentially just are opening a direct peer-to-peer message with someone else. And so you really don't have any traces of that. And then it opens up, as I said, an encryption system on it so that developers can not only develop peer-to-peer messaging applications, but you'll be able to actually develop peer-to-peer communication, secure communication between apps or dApps or between users, right? So it can be any data, right? The messaging is going to most likely be a big use case, and that's something that we're going to develop as a module and potentially another standalone mobile application that'll be like a peer-to-peer chat, which will allow you to say, okay, here's a good example. I need to send funds to someone, but I don't feel right about sending the funds until I know that they're online. So I'm going to open up my peer-to-peer messenger and I'm going to send a message to their username. And it'll all under the hood, it'll find all the IPs and hide it. And I mean, it's going to be acting kind of like a VPN. So I'm developing it towards the direction of Tor, right? Right now it's pretty peer-to-peer, but the initial VPNs are going to have this Tor-like function where you can pass it around so you really mask and hide some of these IP addresses. And then, some of the seed nodes are going to actually work as reverse proxies, which means that you make an outgoing connection from your computer to this reverse proxy, and then another person makes an outgoing connection, and then that opens up this basically a tunnel between the two. Now it's all going to be encrypted, so there won't be any ability for somebody to man in the middle and spy anything. And the encryption techniques that we're going to use are going to be post-quantum. So the one that I'm mainly looking at is Saber, and we use Falcon still, which I don't know if anybody caught that, but Falcon won the competition for the new NIST post-quantum digital signature algorithm. So that was definitely a good point. Let me see. Seems like there we go. Got a little blurry for a second. So we have so it's going to be post-quantum, right? So it'll be peer-to-peer. And it's not, the 5.2 is not going to be like a standalone peer-to-peer messenger, right? Think of it like as a framework, right? So it's going to allow developers to develop, whatever they want on top of that, which is, hey, I want to have my own private peer-to-peer messaging system. Okay, I'm going to develop my own private app, or I want to use Nexus's app and whatever. And it will allow you can either do it on your own private network, or fire up your own hybrid network, or you could do it over the public network. But that's really going to increase the security of communication. I think that's something that's really, really important right now, because there's so much censorship everywhere, right? And this sets a foundation like Sohan with your Society app. You'll be able to add basically direct messages with the peer-to-peer messenger API really very easily inside your app. And the other really cool part is that we create it kind of like a network rather than an app, right? So when you're running these chat apps, they're actually running a node on board and they're processing traffic for other people. So it remains fully decentralized and it can't be shut down with Signal or Telegram or anything. It's still shut down. It's easy to shut down. If you just go shut down the servers, then goodbye, right? A lot of ways that they've been canceling things is through the hosting services, like AWS has been canceling a lot of hosting for different people that are speaking out against the mainstream narrative. So this is kind of a step towards that, right? Once we get to the full-fledged file system, that's going to be another really important feature for that decentralized hosting, right? And then that'll come built in with the decentralized search functionality, right? Integrated. So these are really important features that I've been developing. Now, the reason I'm developing this specific peer-to-peer messenger API is because I think that's our first step to having, we need to be able to freely communicate with one another. And it really adds a nice dimension where you don't have to worry about, verify this or verify that with phone numbers and this. And, is this Signal server compromised? Are they actually encrypting it? I can read their source code, but like how much really are they saving and retaining, right? Do they respond to subpoenas? Telegram's a Russian company. I've seen certain, moves towards censoring it a little bit more. So this will really help a lot with some of that censorship and the open, free communication between people. And that's something that, Nexus, that's one of our ethos is just, we believe information should be free and available, and everyone should be able to communicate freely and openly, right? So the peer-to-peer messenger API is a really important component to that. The next one is the crypto API. If anybody is a developer and has basically done any, working with cryptography, it's not easy. And I should say this: it's very difficult to do it correctly. And it's very easy to not know you didn't do it correctly and open up gaping security holes, right? And that happens a lot. So the crypto API is essentially going to allow you with just a web API to encrypt and decrypt files, messages, everything like that. So you'll actually have encryption at your fingertips without ever needing to touch encryption, right? The framework itself will support that, because there's a lot of, there's a lot of encryption out there, but they always come down to this fundamental issue of key management. I was just talking with Dino, if you guys remember Dino Farinacci, a bit ago, and I'm actually continuing to work on our draft with list decent, if you guys are familiar with that. Decent stands for decentralized, because when Dino and myself first started talking, he gave me the whole spiel on Lisp, and I was like, that's really cool. I really like that, but Dino, it's centralized. And so Dino was like, oh, okay, let's figure out how to write a decentralized list. So that's where that whole document, I can paste that working document here, but I'm working currently right now on a key management system for Lisp, crypto, and decentralized Lisp, because they're running into the issue when you're running a crypto EID, which, if you guys recall, an EID is like a static identifier, right? Lisp runs like layer 3. So basically, it allows you to have a static IP address, but allow it to dynamically change underneath, right? It's an overlay, is what it's considered. And the crypto EID is essentially a cryptographically authenticated endpoint identifier. EID stands for endpoint identifier, and this is Dino's architecture. If you remember, Lisp, locator, identifier, separation protocol. In other words, your IP address and the location of like where that packet is being routed to and the identity are decoupled, right? So your identity becomes the EID, and then your RLOC changes. A good example of why you need this, peer-to-peer messaging for good, right? I need to send a message to someone, but hey, you're on LTE. Oh wait, you just got on a Wi-Fi. Oh wait, you just went to a public library. Now your IP address is constantly changing, right? And so it's difficult to know where someone is. So this way it allows you to open up just a connection to their EID, and then underneath the hood, it does all of that routing for you. So, but with a crypto EID, it requires a digital signature to authenticate and register in the mapping system. But as you know, whenever you deal with cryptography, you have a need to manage the keys. And that's not always necessarily the problem. The problem is when you lose the keys. I can't remember the exact number. It was a pretty high number. I think it was like 70 to 80% of all the Bitcoins are unspendable, right? There's a lot of, or not the Bitcoin, sorry, the Bitcoin transactions. I'll have to pull that, I'll paste it in the Telegram community, but it was a really high number, actually. There's a lot of coins that are unspendable because people lost the private keys. If you guys have read all the horror stories of, $300 million, my girlfriend threw away my hard drive because she didn't like the fan being on, there's a lot of that. So this solves a key management issue, namely, that's the biggest thing. And also, the user friendliness of dealing with encryption. So that we really want to give people access to encryption. And, it's not something that's very well known. And you have all these, like I said, nuances. If you don't do it just right, then you can cause all these different security flaws. And if you lose your keys and you have your entire app based on the access from that key, then, you're SOL, right? It's gone. You're not getting back in unless you create centralized recovery systems. So with a SIG chain, it allows us to generate these keys and have key management. As you guys know, I've talked about that. And that crypto API is going to come in to Lisp, right? I'm going to probably be attending one of the IETFs again soon and presenting some of my new drafts. We've been talking about that. And he was introducing, saying, yes, they have a serious issue with key management right now for crypto EIDs. Surprise, surprise, right? If anybody's ever seen an app that's called Keybase, it's like a Slack, but it's an encrypted Slack, or you have to make like a paper wallet. Just like, come on, like you have to make a paper wallet to send a message. Like this is nobody. Like it's cool for geeks, but like what happens when I lose my key, or what if my phone falls in the ocean? Like bye-bye. Oh, I don't have a paper wallet. Whoops. It's gone. All of that work, and people really don't like losing files, right? So that's where I think one thing that has been really inhibiting encryption from reaching more mainstream adoption, right? Is you have to manage all these keys. And so, you usually rely on some sort of centralized key management system, like, MetaMask, if you guys have seen. That's the only way you can run smart contracts on Ethereum, because you have the key management issue. So MetaMask manages all the keys for you and gives you a login and then give you access to your smart contracts. But they really are just like a giant exchange. They own everything, right? You don't actually have your private keys. So the crypto API will really, really help with that. And it will also make it more available, so that you should, with just a simple little web request, be able to say, hey, I need to encrypt this file. And you'll give a link to the source of the file, and then the API will run it, encrypt it, and it'll spit you back a big, nice base64 encoded, encrypted file. So you'll be able to actually run that, and it'll be really cool because you'll be able to run that as an endpoint too. So since the API is an endpoint, you can have a file local on that system, let's say on that node running, and then you can make a request. Let's say the file's encrypted and you want people to access like a decrypted version of it if they have the correct username or password or whatever. So you can actually make that endpoint hook into the crypto API and download that file off. I'm going to make it so it supports different file encodings, and it's all done through HTTP too. So it'll be like when you type in that API command, you'll basically get a file download request, right? So you can download that file right off of that API. So that's going to start, that'll be a local file system, right? And then 5.2 is going to come with the file system API as well, and then the remote login. So the file system API initially will just be an API where you can upload files in and out of that specific node. And then another really important part is making those files hostable, or creating a sharing link for them. So since the API is a JSON or HTTP JSON, it supports regular web browsers. So you'll be able to fetch files, upload, download files to that node through that API. And initially, the file storage mechanism, you'll be able to adjust it in the future, but the first version of it will obviously just be a local file system, and we'll get to the remote file system where you can just upload a file into your node, and then that will disperse out into other computers that host that for you, and then you make that file discoverable, right? You make it a publicly linked file, then you'll get a link back, and then other people will be able to follow that link to download that file, which downloading a file is going to a web page, right? When you go into a web page, you're downloading the HTML from that web server and then rendering it in your web browser. So it'll give you the same feel of running a website, right? So you'll start to get like, hey, I'm going to make a web page. I'm going to load it up in the file system. I'm going to make it publicly accessible. And then with that link, you type in there, which that can be a link for any node that supports that file or has access to that file. Boom. It'll be like going to a web page and it'll load. And since it's all in a web browser, now you have decentralized hosting, right? And that's another really important component, to all of this, because this hosting is getting censored left and right. And I haven't really been satisfied with any of the decentralized file systems that people have tried to develop so far. I think there's a lot lacking, and architecturally, like Filecoin, for instance, it just there's a lot more problems than it really solves. And another big thing is like the scalability of it, right? Distributed hash tables are cool, but I've been developing other type of architecture. It's kind of like, I guess you could call it a distributed Bloom hash map. Think of my LLD architecture that exists, in files on your computer, where you have, your hash map and then your Bloom filters, and it operates in constant time. Think of that spread over a distributed network, right? The hash map can mod to any specific node that's from a list, and then you connect to that. And that's also what the LLD is going to do too. Maybe not in 6.0, maybe in 6.0. I don't know. I'm developing a sharding mode. So right now it's non-sharded, but you'll be able to break up the data set. So if you want to run your node in shard mode, you'll basically shard or hold a smaller subset of the database, and then that'll be split up among a number of predetermined shards. We'll probably start with like 8 shards or something like that. So that'll break the chain up into a certain size for each one of those, but it will make your processing a little slower, unless you have caches of those objects you need, because you will be requiring a remote lookup and downloading that off of them instead of just doing a simple disk read, right? But yeah, that's coming too. I just wanted to, while I'm at it. So the next part of 5.2, that's another really, really important feature, is login with Nexus, remote login system, right? If you've seen login with Google and login with Facebook and all of that, as I've observed, not just myself, but other people on the internet, there's a big problem with passwords. I mean, it's just even trying to change my auto pays for my bills. Like, oh wait, what password is this one? What password is this one? What's the email for this one? And then they have all these stupid securities. Like, oh hey, you put in the wrong credentials. What is it? Oh, this one's a username. Now this one, my username is my email. And like, it works, but I think there's better ways to do it. So I'm developing, this is for 5.2, a consistent login with Nexus function where, as a developer, you'll be able to, have a login with Nexus support. And that'll kind of essentially be a similar kind of API. I'll model it off of existing authentication APIs, but it will allow you to use Nexus and your node as an authentication system so that you won't have to develop or use OAuth, for instance. Developing a secure authentication system for a web app it's cumbersome, and it takes a lot of skills to do it right. This way, we'll make it available for everyone. You can just piggyback off of the Nexus login system. But the remote login, what that ends up doing is it'll allow using, peer-to-peer communication. You'll have your phone, and then when you go to a web app that says, hey, log in with Nexus, you click login with Nexus, it'll ask for your username. You type in your username, click login, and then your phone, as long as your wallet's open on your phone, it'll pop up and you'll get a notification to say, hey, this web app is asking to, access your SIG chain. Would you like to create a new profile, or would you like to use your master profile? And you'll most likely want to create a new profile, and then it'll fire up the SIG chain and it'll kick back to the web app a digital signature, and a timestamp, and probably a random nonce too, so that you don't have replay attacks. And boom, you're now logged in on that web app, and now that web app now has access to blockchain functionality without actually having to run a co-located node doing all of those processes and requests. This will be really important because generating a transaction on Nexus takes a lot of time and energy. Algorithmically, that's by purpose. That's our brute force protection, right? Using Argon 2. So running a single server web app, generating transactions on it. It can process transactions ridiculously fast, but it's slow generating transactions for a reason, right? So as you get lots and lots of users running your app, you don't want all of that transaction generating to be happening on your one node. You want to have a little cluster of nodes that you're running your web app on, but then you want to offload that computation to other devices, and that's where the remote login system helps, right? It's going to offload the transaction generation onto my local device, so that if whatever I'm in the web app, it'll kind of feel like two-factor authentication for the web app, right? If you've ever gone into the Google 2FA that they have now, like you have to go in the YouTube app and then click allow, and just think of it like that. That's how it's going to feel. So you get this side benefit of two-factor authentication, and then it also increases the scalability of your web app. Especially Bubble, I know, doesn't let you cluster. It doesn't let you have more than one API node. You can only run it through one node. So the remedy to that is have the node act like a load balancer and offload computation onto other nodes, or using the remote login system. And those two together should suffice to create 100 million users if you really want, because a lot of your actual load of transaction generating will be offloaded to the actual local devices, right? And then the other really important quality of that is you don't have anything to hack anymore. The developer that develops the web app doesn't have to worry about all these security protocols for making sure you salt the password hash and keep your database secure so people don't grab all your password hashes and stuff, right? It will be very difficult to hack because there's nothing actually on the web app and nothing going into the web app. The only thing that you get is a username, right? The web app, and so the web app caches the username and has their own database to track their own, related metadata. But when they need any sort of action required that requires your PIN or password or whatever else, it's going to offload that to your local phone, your mobile phone, and you'll have to click accept, or it'll say, hey, we want to generate a transaction for this web app, click allow, or you can, say ask me every time, or, ask me only once, those whatever security protocols. And so that way you get these really cool benefits. And I think it'll really change a lot of how we see login systems, how we see, web security. We won't need to store all of this data on a database anymore that can be compromised, which means, people's data can't get stolen, people can't get hacked as easily. And you really eliminate phishing completely. Phishing is where, if you guys aren't familiar, you create a fake login page, and then you trick someone into putting their credentials into that. The web app will not actually require any credentials to be put in. You'll just have to type in your username to link that, right? Your credential management will all be done on your local device. You'll be typing it in on your local device. You'll type your PIN in and your password. So nothing will go over the airwaves, right? Nothing will go into the web app that's any personally identifying information. And then creating a new profile will also allow that to be decoupled from your primary SIG chain, so that, you know, if you have Nexus on one SIG chain and you don't want the web app to know the Nexus, you just create a new profile. And what profiles do is, think of a profile as just like a separate SIG chain that's managed from your primary SIG chain or your primary credentials. So under the hood, it's just going to be creating a different profile name, and then that will be its own individual SIG chain, but it'll have a similar credential. But it won't be the exact same credentials as your master SIG chain, but you'll be able to manage it from your master credentials, if that makes sense. So you'll be able to create profiles for all these different types of things, right? And as you're seeing this, if you're putting the two and two together, Sohan or anyone else, you'll start to see that there's this decentralized social media type functionality coming into the API, where Nexus in itself almost, you know, becomes a larger part of, you know, a way to socialize and interact with one another. And so people like Sohan can build, you know, these apps or dApps on top of that framework, you know, to allow people, you know, so you'll, you know, Sohan have access to these profiles and all these different things, which is, I think, a really, really important feature. And then let's see, that's remote login, crypto API, peer-to-peer API, and then the file system API. I briefly touched on that. Distributed file system, distributed hosting. My ideal scenario for that would be one-click deployment, basically. So from within your wallet, you should be able to select a file that you want to upload, and then boom, upload it, done. And host it too, which means you don't have to go get a new droplet and go to cPanel and configure your cPanel, and then open up your FTP and then upload your file to the FTP and make sure you have your CGI config set right, and you got your Apache config set right, and got to get the database set. I mean, there's so many cumbersome details that go into hosting and developing that this is just going to eliminate, right? We want to make it really frictionless for people to deploy web services, because information should be free. It should be easy to transmit. And it should be available for everyone, but also, you know, the integrity of it should be verified too. So another, you know, nice feature of this file system is when you go to this specific website, you'll be able to actually know if you got, you know, a bad website. Like, for instance, if you have a virus on your local device and somebody's sniffing your packets, they can modify the contents of your packets, which modifies what you receive in the operating system level. And that essentially makes it so you can add whatever the hell you want. This will prevent that type of thing, packet sniffing. You'll know exactly immediately that that web page was tampered by whomever, right, that who's delivered it to you. So you'll get these new levels of integrity, and then you'll also be able to see version histories, right, and all the modifications to that. So those are some really cool features, really important features. And then, as I said, 6.0, we're going to be deploying the new lower level database with constant time. I have some lockless data structures developed, very basic right now, but that's another really important thing. That's really not very, I went down that rabbit hole like about it less than a year ago, because there's no lockless data structures out there. It was really difficult to find anything. I think Facebook had a lockless queue, but it was a really crude design, I guess you could say. And you know me, guys, I just, oh, hey, wait, nobody's ever done it before? Hey, sounds fun. So yeah, those lockless data structures, it outperforms the STL containers by about a factor of 3. So what the results of that is, it'll be much faster, less thread contention. People won't be, you know, fighting over shared threads, won't be fighting over shared resources anymore. And then the LOD shard mode, right, which will be really easy to implement, so that you'll be able to run your wallet in a sharded state, right? So you still want to run a full node, you still want to stake, but maybe you only have 4 gigabytes available. Okay, I'm going to join a shard, or I'll join 2 shards, and I'll provide data for those 2 shards. And that'll be kind of a nice way to phase into the sharding system. And this will just be a data sharding system. It won't be computational or process sharding. It's just, I'm sharding this database into multiple groups of nodes per se, and then your node, based on your Genesis ID or your node ID or whatever is generated randomly in the beginning, will hold and, you know, participate in that specific shard, which means data relevant to that shard will get committed to your disk. Everyone will always have the same blockchain global state. You'll all have, you know, you'll know the blocks per se, but you'll you'll save different elements of those blocks and transactions on different nodes. We'll probably end up having everybody have like the same block structure, which shouldn't ever go over a couple gigs. But we'll figure out all those specific details later. But what the end result of that means is your database will not require as much disk space. And then when we have just even a basic 4H shard, then new updates, we can be like, okay, 16 shards or 32 shards, just to continue testing it and scaling it out. And that way we'll make it a lot easier for you to utilize. One thing I forgot to mention on 5.1 that's a really important feature is the client mode, if you guys are familiar with that. That's what makes your mobile wallet work. And the mobile wallet, what's happening on it is you're actually running an embedded node. That's running a light node, which is viewing the specific blockchain data relevant to you, but not the whole global scope. So by default, I would like the wallet to start in some client mode, right? And then you can synchronize for your full node after that. And that's another big feature that will probably, I'd estimate about a gigabyte, maybe half a gigabyte of memory required. I haven't checked the database more recently, but last I saw it was, I think, like 300 megabytes or something like that. So that will be your disk requirement for the blockchain. You won't be able to stake in light mode or client mode, but you'll be able to use the wallet. So that should get our setup even faster than it is right now. And we're working on some other features too, Kendall and me have been talking about, embedding like a bootstrap in there with the mobile wallet when you download it, so you don't have to download off the network and it's faster and different things like that. So that's pretty much the 5.1 stuff. Like I said, I give it a couple weeks. Obviously, things can change, things can take longer, things can take shorter. But I'm going to definitely let you guys know on the next development update how all of the bugs are going, how they've been resolved, and what we need to do next, and what specific features that I've been developing on the 5.2 core. So that's essentially what I have for now. Looks like I did good. I did 50 minutes. I'm going to open up to AMA, but all right, I'm going to. New participants can speak. There we go. I'm going to start going through some of our questions, and obviously if you guys have anything that you want to ask directly, feel free to speak. You should be able to unmute yourselves. Just make sure you don't talk over each other so I can understand. Noise reduction, yep, live stream, the piano, more difficult to implement a VPN or messenger. The VPN's a little bit more difficult, I would say, Robert. Just because it's going down into layer 3, I'm going to have to be capturing the packets off of the network interface and then encapsulating those. But in a sense too, the encapsulation isn't very difficult, but I won't be able to use the lower level protocol like I've already developed, or the reverse proxy. So the peer-to-peer messenger API has a little bit more context for things that are already developed, so that'll be a little bit easier. But the VPN will, probably take a little bit longer. But this is something I was chatting with Dino about it, and essentially Lisp acts like a VPN itself. So I'm developing our own version of locator identifier separation protocol. One reason why we're not deploying Lisp in Nexus right now is because it was built mainly for Debian, Linux Debian based systems, which is like Ubuntu and Debian, Kali, Debian based. It's pretty locked in with that specific operating system and its framework. So I've been developing, I haven't developed it yet, but I should say I've been developing it in my head, but it hasn't reached the fruition of code yet. But developing a new Lisp that will run natively on iOS, Android, Windows, and all of that. So the Lisp currently, Dino's version implementation of it, does not support Windows. So that's one reason why we didn't support it, because we had to actually put it in a Docker container, and there's a lot of dependencies. So when I developed that, that's going to go in parallel with the VPN. Right? That essentially is a VPN. So I'm going to be designing it so that when you're running Lisp, you're essentially already plugging into a VPN. That's one faucet. That'll probably be a little bit later. The earlier VPN, we were talking about 5.2, 5.3. I've been studying the OpenVPN protocol. That's really important. I wanted to support a standard protocol that other people already support, right? I didn't want to I could create my own VPN protocol, and that would be much easier, honestly. But I'm going to support the OpenVPN protocol. So I've already gotten their protocol specification document, and I've been reading through and consuming that. So you should be able to connect any regular VPN client, or feel like a VPN client, and then have that switch. For instance, like I utilize VPN for my phone and things like that. So we'll be able to test that in, because I would like to have some level of backwards compatibility with existing VPN system. I would ideally like it to be where we don't necessarily have to install a VPN software on top of it. It should just come out of box. So yeah, that's Messenger's easier in many words. Okay, theme ad, quality and background. Thank you. Tasha helped. She clean it up, and I didn't do my nails, but I got a little shaved, and yeah, people have been commenting on my ragged appearance, and they wanted me to look a little bit nicer. So here I am. I figured it probably wouldn't hurt to do it inside, and so yeah. Thanks, theme ad. Thanks for the tips too. I think I needed to step it up quite a bit. Sohan, what's your take on making non-transferable, non-fungible tokens? Binance just really launched account bound. Non-transferable NFTs is pretty simple. With essentially, once you get augmented contracts, you just do an operator overload for a transfer operator and then make it non-transferable. I mean, that to me personally, it's become a back burner feature, because I don't like it. I don't like non-transfer. I understand the need for it. Okay, but philosophically, I just don't like oh, there's a master owner, they can revoke ownership type situations. But I understand the need for it, and I've kind of had this ethical conflict of like, should I build it? Like, that could be really abused. What are the benefits that it could usurp those losses potentially? So that'll be a natural byproduct of the augmented contract framework. Like I said, you just overload the transfer operator and you add a function in there that adds additional logic to it, and boom, you'll have protected assets, protected NFTs, non-transferable, I guess you could say. This could support soulbound use case going around non-transferable. I can build a fully on-chain self-sovereign ID. Yeah, I mean, you could have the non-transferable in that way, but you don't really need non-transferable assets to have a self-sovereign ID system. But I do see that there is a need, like if you have like a badge that somebody awards or something like that, you need to have that. So that's coming probably closer to 7.0 when I get the augmented contracts framework put together. But that's definitely in the pipeline, but not necessarily as a direct feature that I'm going to develop non-transferable assets, but it'll be a byproduct of the augmented contracts, if that makes sense. Say something about namespaces and global domains. Give some understandable examples of usage. Okay, let's look at the file system and the hosting that I was talking about earlier. I have a file, I need to host it. That's going to be, a register address. It's going to be hash. You're not going to be able to, go in that. Okay, well, I want to create a namespace, which think of that as like .com. I'm going to create .nexus or, :nexus, and then I can therefore sell names within that namespace. So I could say, look, :nexus, for instance, and then that name will resolve to the register address that then can ping to that endpoint that then will deliver you the website. So that will essentially build its own. One really good example is using it kind of as a DNS system. Another important example is, hey, I don't want to memorize these big, long alphanumeric, values for someone's address, and I don't want to paste this address in something or send this address because I want, some level of anonymity. Okay, well, I can send to your username :default, or, if you don't want your username to be revealed, and you want people to still be able to send to you, you create a namespace. I think somebody made like a send.to namespace, and then you put a name within it, send.to :viz. And then you essentially have this resolution. Under the hood, it still uses raw addresses, but this is a layer of indirection on top of that, so that you can essentially resolve that into a name, and you get this specific register address. So like I said, an example would be if you're accessing hosting, or another one if you're sending to someone, or those things could simply point to an endpoint that could be your chat location. Hey, chat.me :viz, whatever, and then that register could contain metadata for your chat information of like, okay, I want to be pinged through this specific hexadecimal value or whatever else, right? So it really makes it so that you can actually type in and not have to memorize all these addresses and paste and copy and double check your first 3 letters and your last 3 letters. You just type it in, and it'll double up into a type of DNS system. Web browsers natively won't support typing in .nexus, right? But we'll be able to develop a web browser plugin, right, like Namecoin did, and that will, allow that support where you can essentially develop this, blah 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 .nexus, and then go into it, and it'll load up and allow you to see. So let's see. YouTube comments. Let me understand. Data requires memory to be stored. How do you imagine a database that will grow in size of today's YouTube database stored in satellites? So the database itself isn't really stored on the satellites. The satellites contain a minimal amount of state, but the state that they really manage is your routing state, right? You have data that you're going to be retaining on the satellite as a type of backup, but you're going to have a lot of ground-based infrastructure as well, right? And the satellites are going to be intercontinental relays. You'll most likely get more like META-related information on the satellite, and really what you really want with the satellite is to create a host route, right, between continents. Let's say I need to access something over in Asia. It gives you an actual way to connect to that data, and that data can be uplinked or downlinked from that specific satellite and move. But as it stands right now, data is ridiculously cheap. So, that question would just be like, well, how much does it cost to have 10 gigabytes of storage on this or that? You're going to have a higher premium value of the satellite, but that's going to drive people to utilize the data retention on those satellites for more important things. And, larger amounts of data, if you look in the white paper, you'll see the file caching and things like that. You're going to cache a lot of that actually on the ground. So, and that's where the geospatial contracts come in, and that's where ground stations start to become something that you can monetize. Content delivery networks, for instance, drive most of the internet's web traffic, right? And that's essentially a server that's closer to you so that you can get the file closer. The satellite will store the replication of the file, and it creates this level of redundancy. But ideally, you don't want to hit the sat for every time you need to download a picture, because you're going to consume a lot of bandwidth, and it's going to be less efficient because you have your latency time. So ideally, there's going to be another ground station in that city that's caching that. If you have a large web app, for instance, and you want to put a geospatial contract, let's say in a large city, you could pay a certain amount of money into that contract, and then people will be able to earn money through the ground stations by caching files for that. So you'll get big apps like Facebook and stuff. Well, essentially create a decentralized content delivery network, and so that allows you to host and have that accessed very quickly with a lower cost and a higher speed, and it also less centralization in that specific type of architecture. Millions of terabytes of data are stored today on hard drives, the weight of which is countered. How do you imagine the hardware that has cost corporations such as Google billions on Earth, plus the cost of sending a satellite into orbit? Yeah, so like I said earlier, this is to the YouTube comment, having the satellite is primary functions is you're not going to put like everything on a satellite, right? It's retarded. What you really want to do is you want the satellites to create a relay between points. Now, you'll have certain levels of data that you want to retain on it, right? Like I have very sensitive data. I want to make sure that it's physically isolated from Earth. That's something that you're going to want to spend. But you're not going to put pictures of your puppies on the satellite when it costs you 5 cents a byte, when you could put it on the ground-based system for a penny a byte, or a tenth of a penny a byte. So the natural cost incentives are going to drive those markets, right? And the price per value is going to be driven. So really, less data stored on these satellites or less data available is going to actually drive a market value. And this is where I talk about the exponential revenue streams, right? You have a cost per byte that's going to basically be on these satellites, and then when there's less satellites and more demand for these bytes, secure data systems, then the value per byte is going to go up. So you're going to get this increasing or decreasing market value per byte, and then you're also going to get this changing ROI based off of the satellites, revenue generated and the constellation and the different services that you augment on it. Think of the satellites as like, you want to do as much on the ground as possible, but you want the satellite to do what the ground can't do. Okay, so for instance, I can't send a signal across the Atlantic Ocean right now because you have the curve of the Earth. That's a problem. So you need to ping off the satellite and then ping it down. I have a sensitive file, right? Let's say schematic or something, and then I don't really feel comfortable having that stored on a geolocated physical ground system. Well, I'm going to upload that to the satellite. Or
let's say I have a web service and I want to add a hook to the web service so that it's accessible via the satellite relay system, or a TNS entry on the satellite system. Okay, I'm going to pay for that hook, and then that's going to be a hosting hook that's going to downlink to another spot, and then you get that geospatial targeting, or the geospatial contracts that do all the content delivery for you there. So that's another really, really important component. Like, you want to do as much on the ground as possible, right? That's really architecturally what we want to be shooting for. We don't want to be pushing and squeezing more out of that than you need, right? You need the satellite to do what the satellite does and the ground to do what the ground does. Ideally, you want to do as much as you can on the ground, but there's certain aspects of the satellite that you want to be able to do. And so the free market, valuation and the demands and the costs and all of that will drive the satellite revenue systems. Also, additional augmented services that you want to add to it, right? Let's say you have a new imaging system, right? Taking pictures of different parts of the globe, and I need, a software development kit that allows me to access those imaging systems. Okay, well, that's going to be, an extra service that specific satellite constellation charges, so that if I want to have a picture taken of whatever geospatial area, that satellite can do that, and then it stores that file in that satellite constellation and allows you to downlink from it, right? And then you can either choose to down and save or not, right? So think of it as there's two tiers. You got your ground-based file system, and then you have your orbital file system. The orbital file system will be storing, it'll be storing data, but you're not going to be putting petabytes and petabytes on satellites. It doesn't make any sense, because you can do it just as well on the ground. What makes sense is there's certain things that need to be more secure, that it makes sense to store that on satellite, or you have some level of caching is needed. Hey, I'm taking this picture, I need to know that it goes directly here if I don't have a direct link down to the downlink, or I'm sending a message or things like that. So think of it more like that, right? You have lots of ways that you generate revenue on it, but you want the satellite to do what it does best, and you want the ground to do what it does best too, right? And you want to combine the two. So that's why the ground infrastructure is really important in the mesh network and how that works. How will Nexus approach an IoT that is not currently standardized in any way? What challenges do you see? Well, IoT isn't standardized. I've got a lot of security friends that are pretty involved in the IoT business. They run the IoT village at DEF CON, and IoT is it's bad. I don't know if anybody's been watching the news, but you've seen those Nest thermostats when they put on the low power time. You can't change your thermostat anymore. It's changing it on you, right? It changes already on you. So, those types of devices, and the other problem is there's such a joke for security. You can hack right into your local network from those things, right? I think Google sponsors those. So, IoT as it stands is not good. There really isn't any standards in IoT. The only standard that there really is in IoT is get it to market as fast as possible and use as cheap of hardware as you possibly can. There's some actually IoT devices that still have admin password to their little admin panel to access the device. It's bad. And there's been people's networks that have actually been hacked from just having a Nest thermostat connected to your Wi-Fi. You can hack into that thermostat, and then that allows you to hack, and then you can ARP poison your local network, and then poof, gone, right? So yeah, the way that we're approaching it is, instead of fighting the grain, right, which is hey, all these people are rushing to market and they're using a lot of times outdated hardware and software because they just want to get it out, we can work with that I guess game theory, you could say. So part of the operating system, LXOS, this is how we're going to really start getting initial adoption for it too, because you're not going to just install LXOS and then everyone's going to use it. It's going to take time, right? So we have the software defined router. That's one important thing, and this ties in with the satellites too. IoT, right? I have an IoT device. It reports to a sensor reading. The sensor needs to be stored. The sensor data can be stored on device, but you're going to want to have a globally accessible point. So it's going to upload that to a satellite, whatever constellation, and then you can downlink that from your main master, web app or whatever else, right? So, that's an important distinction right there. But think of the IoT and the Cube satellites as being merged together in phase one. Phase one is really just a command line CLI operating system that's consumer grade, that allows you to or that's not consumer grade, sorry. CLI stands for command line interface, that allows you to essentially just, build an efficient, fast IoT device really quickly, out of box, without having to mess with too much stuff, and also while it has security, right? Built-in security protocols like that it makes it difficult to make it insecure, and it makes it more cumbersome. It takes more resources to develop one that's insecure, right? Like Nest, for instance, like I was saying, you can hack your Wi-Fi through it, or they can turn off that thermostat whenever they want. This, you won't be able to do that. And you'll have this other aspect too, where you have like a device security authentication. So you remove the attack surface from the actual device and move that to, I guess you could call it the blockchain, right? Because the device itself will have to be registered, right? Let's say I have a smart light or a smart light bulb and a smart thermostat. You have to register that device, which each device will have its own embedded sig chain. But then you'll have another sig chain that's your master sig chain that controls it, and those will be a multi-sig 2FA, right? It'll be a next hash script with an AND Boolean operator, which means you require a signature from both, so that the device, even if you actually physically penetrate the device or electrically penetrate it through Wi-Fi, you won't be able to attack it. You won't, because you'll have to attack the person's sig chain credentials that are not embedded on the device. So you'll create these really high security properties, but you also solve the device management issue. If anybody's ever seen, and this is something Dino complained about, and I was like, thanks, Dino. I listen to complaints because those are problems that need to be solved. You have an app for each different IoT device. I have this light bulb. I got this IoT device. I can change my color of my light bulb. Oh man, check it out. See, but oh wait, no, but my Nest thermostat. Oh, here's my other app. I got this one. I can change my temperature now. It's really bad. There's no consistent standard. There's no consistent interface. So this LXOS framework on the IoT side will support all of these, new security protocols. It'll make it, a lot more efficient. It'll remove the attack surface from the physical device. It'll come basically as a secured framework. But then on the other side of it, just like you can install modules in our wallet, there can be a generic app that runs and interfaces with all LXOS devices that are registered under that specific sig chain, and then allow the developers to develop a module that plugs right into that app. And now, boom, I can manage every single IoT device that I own that's running LXOS through a single common app, through a modular framework. You just install these modules directly into the app, right? And then obviously that can create app stores and things like that. So that's the way I'm approaching IoT, and I think that's the best way that we can get our foot in the door, getting an operating system out there, because people use what they can use, and most people use Windows because that's what all their apps are built to run, right? LXOS, when you get to the consumer grade, well, if anybody's seen Cube's OS, I would recommend checking it out. It's a very interesting operating system. It's Linux based, but it creates a virtual machine for a different cube, so you can create this disposable cube, and you can keep things in these isolated virtual machine environments. That's how Windows will work on LXOS. You'll fire up a cube that has Windows Sandbox in it, right? And so the Windows will only know its own little virtual machine self, and it can spy on all that little virtual machine self, and you basically create a single instance to run that application. But the majority of all, everything you're doing will be on the LXOS side. So it'll eventually support all those apps, because that's the only way we're really going to get adoption. That's the biggest reason that Microsoft has such a stronghold on the market, is because everybody uses, Microsoft's, .NET framework and everything, and all the apps are built on it, and it just becomes cumbersome. So the IoTs are the first step, as I said, and then that drives the demand for the satellites and the satellite relays and the satellite data retention systems too, because IoTs are going to need to report. There's lots of companies looking into IoT and blockchain, but nobody's really gotten it to that point, right? And IoT devices are very light, and people want to use blockchain-like functionality. So this will be, boom, install this operating system, and then have a rapid development application framework in LXOS that allows you to develop it very simply, protects against developer mistakes, and allows them to deploy it to market without actually having to do as much as they would have to do running a basic Linux kernel, something like that. So that's the way we're going to get our foot in the door, and that's our phase one, as I said. And then phase two gets into the actual consumer grade operating system, which another really important distinction of that is it's going to be a three-dimensional interface. So have your two-dimensional windows and stuff. This is going to be a 3D world, right? So using your computer will almost feel like you're playing a video game. And that's as a step towards augmented reality and stuff like that, right? So that's going to be another really fun part once we get to the consumer grade. And these are all, as if you've put together, these are incentives now to connect all of these things and to get people utilizing the software and the operating system. How complicated is building the remote login, and how long will it take after 501? The remote login is not incredibly complicated. I mean, it's no more complicated than the peer-to-peer messenger API. It really, in my head, it's pretty clear, and this is why I suck at time, as you guys have noticed, because it's so clear in my head. But the process to that, completion sometimes is a little bit different than I anticipate. But as far as I see, it's really not very complicated. We just need to add the profile system in. And then you just basically need to run, like, since I've created all these templated frameworks, the lower level protocol, I just run an LLP that runs directly into the node and then, invokes requests. So it's really not a lot. I mean, I just have to basically add a little protocol that allows the two nodes to communicate, which, is essentially I guess you could call it a use case of the peer-to-peer messenger API. I mean, I could very well just piggyback on the peer-to-peer messenger API and kill two birds with one stone doing that. So it's not too complicated. And 5.2 is I broke out all these different features. We can break that up into smaller incremental updates if you guys want to. We can do a vote on that or whatever else if you guys think. And like of prioritizing features like, hey, we want remote login and peer-to-peer messenger or crypto API first, or whatever else. So just want to put that guys in your guys' ears. Let's stay involved in that and setting these expectations, setting our deadlines, setting our timing. That's really important for us to have that consensus, right? Because Nexus is all of us, right, guys? I'd just be a guy sitting here typing and talking to myself if it wasn't for all you guys. So, we all have our parts to play. I just want to just be really clear. You guys have a very important part too. Almost more important than my part. I mean, I'm just the guy that builds it, but you guys are the ones that bring it out into the world and share it and use it and give it context and give it value, right? Without you guys, it'd just be a bunch of code. So make sure to just stay getting involved with the community. If you see something, do something. It's really important because really that's what'll topple Goliath is a network effect, right? Exponential growth. And you don't really capture a network effect if everybody's waiting around for me to do something or someone else on the team to do something. We all have to pick up a little piece ourselves and do something together. And that will really drive our adoption. And it just there's no stopping it, right? When it becomes exponential. And when you get people all over the place doing it, it's unstoppable. And here, something that may not be directly in context of this conversation, but it kind of came into my mind. This is just an example of how we're going to be doing a network effect. Like with impressions, for instance, I've been playing around with this idea where I develop kind of like a geospatial contract, I guess you could say. But what you do is you inject money into a specific geospatial area. Let's say, I know Ozark man, he's been getting people in Thailand to accept Nexus at restaurants. So when the mobile wallet's out, we're going to create a type of affiliate program where you'll be able to say, hey, 100 Nexus goes into this city in Indonesia. And, for every 10 wallet installs or every 10 wallet installs and SIG chains you get created that are verified to a phone number, then boom, you get one Nexus. And then let's say for every restaurant you get to accept Nexus, you get 100 Nexus. So what you're going to create is these small little local circular economies, and people that are already getting people to install the app will get paid now to do that. And those few Nexus could be food for the day for someone, right? So you're going to create the ability for people to start directly monetizing and doing boots on the ground. And then what are you going to do with the Nexus that you've earned? Well, you're going to want to spend it, right? Well, go to the restaurant that you just got to accept it, right? And boom, now you start creating these natural network effects that we can just feed money into these geospatial contracts and it'll just take off on its own. So that's something I'm going to be developing post 5.1 for impressions. To essentially is just be an affiliate network so that we'll be able to throw funds into these contracts, and it'll be a global system for that tracking affiliate program. So you guys as community will be able to crowdfund and throw Nexus in different areas in the world that you think need to start getting more wallets installed, right? And that I think will really drive a lot of our network effects and boots on the ground, and we're going to incentivize that, right? So that's something to look forward to too. Haley, any possibility of developing wrapped tokens, i.e. W Bitcoin on the peer-to-peer marketplace? I mean, I've looked into the wrapped tokens before. As it stands currently, like I would really like to move Bitcoin onto Nexus, but for now, no, I'm not looking. From what I understand, as far as the wrapped tokens, they require some sort of either burn or like contract where they're locked in on the other network. And I believe, if I recall correctly, they require some sort of bridge. And just so you guys know me, okay, if it has any element of centralization, I'm not going to do it. Okay, it has to be as purely decentralized as possible because that's the long-term goal, right? I mean, if sure, build a little bridge and wraps a Bitcoin and whatever, and then boom, oh wait, the bridge got hacked for $200 million. Wait, what? Solana? Huh? How often does that happen? This is why we don't have centralization, right? There's many other philosophical reasons, but if you want a fiscal reason, that's why you get hacked, you get stolen. But we have been talking about doing key management for Bitcoin. So with the crypto API, for instance, I can add a function in there where you can create a private key for Bitcoin management through your Nexus SIG chain. Okay, so you'll be able to do key management, and then I'm going to also develop a lower level database Bitcoin node, Bitcoin Core, right? So I'm going to take Bitcoin Core as it stands, and I'm going to drop the lower level database in on top of the Bitcoin Core, and I can add some extra bells and whistles that'll connect it to your Nexus SIG chain, so that you can deterministically generate. So basically, you'll be able to hold your Bitcoins in your Nexus wallet, but they're not going to actually be in the wallet, right? But we'll have a Nexus version of the Bitcoin wallet, which, one benefit of the lower level database as it stands is you get a 30% reduction in disk usage, right? So you drop 100 gigabytes off of a 300 gigabyte blockchain. So people will use that, and it'll be instant load. Obviously, all the nice features of Nexus. And that's another way that we can start giving our technology back. And also that'll neutralize a lot of the maximalism narratives. Okay, well, Bitcoin maximalism, but wait, didn't Nexus develop a database that saved, 1/3 of the Bitcoin blockchain size and sped it up by a factor of 5? Well, that doesn't sound like a shitcoin now, does it? So that's, I think that'll really help in unifying some of those dualities, right? And, so that's in the pipeline. I don't have a definitive time on it, but not wrap tokens per se, but key management, Bitcoin key management, which means you won't be able to lose your Bitcoins if you lose your private keys, and you won't need to save a wallet.dat anymore. And we can make our version of the Bitcoin node support wallet.dat or support our key management protocol as well.
Bump, hi Colin, do you foresee possible issues in the future whereby the low-level orbit might become overcrowded? Honestly, the low Earth orbit is not very crowded because the satellites decommission. So when you're conventional satellites that everyone thinks about are the ones where you get a dish and you point into the sky, and it's just the same point in the sky. The reason that is at the same point is because the orbit of the satellite is at the same speed that the Earth orbits, right? If I remember, if memory serves, I think that's 27,000 miles, how far away it needs to be. So that's why you get this really slow uplink, downlink or latency, I should say, from the satellite, conventional satellite internet, is because you've got to travel 27,000 miles there and 27,000 miles back. I think speed of light round trip is 1 second for that, at that speed. So low Earth orbit, on the other hand, it starts at about 100 miles. I think we're shooting for our inclination about 250, 300 kilometers. But you are going to have some sort of crowding. But as far as it stands now, they decommission. So when you're in 100 miles, I think it decommissions in 9 months, which means it just falls into the atmosphere and burns up. And that's pretty much how it is. You have different inclinations you're gonna have to worry about, but we're actually going to develop our own registration system so our own orbital registration system at a certain inclination, which means you'll have to actually buy a cryptographic space in order for your satellite to be able to join the routing system. And this will allow you to have this management of the orbits, and we will make sure that the satellites don't get overcrowded, and then you create another secondary market for real estate, satellite orbit real estate, I guess you could say. And then the LXOS routing system will tie in the need for that orbital system, or that route, in order to join the constellation. Otherwise, you'll just have a stray satellite flying around, and the other satellites will ignore it in the routing. So you'll basically just isolate yourself unless you purchase one of these. And that can go to add funding for serious technology and research. That can go back around and fund research and development projects for other people. And that'll also help us maintain our orbits. And that'll also allow us to scale out the different orbital shells over time a lot easier than it is right now. Right now, I have it designed about 500 kilometer inclination, or 500 kilometer above Earth, and then 500 kilometers apart, which if I remember, is 40,000 kilometers for your radius, about 80 satellites per ring, and then you need a certain number of rings. And then, as I was talking last time about developing new types of propulsion system, whether it's propelling ions or studying different high voltage effects, ideally what I want to create is a type of solid state propulsion system, so that the satellite itself could either have a drone lift it, or itself could launch itself. And then when you have this orbital real estate cryptographically authenticated, that's all geospatial, then the satellite essentially could just fly itself to that point and then stay there. Or the little drone that delivers it could do the same thing. So at the current
schematics, it's about 380 watts per kilogram of lift with the current, testing of the B-field Brown effect. And it's unknown how effective it's going to be in the vacuum of space. I know that people have still tested it and gotten lift with vacuum, but we might need higher voltage. And then, there's other different designs of how much, voltage are we going to run? Are we going to run pure voltage, so on and so forth. So there's a lot more questions and answers there. But the basic idea behind that bump is you have the orbits are all going to have their own cryptographic real estate. So you'll have to purchase one of those orbits or one of those slots in that orbit in order to deploy that satellite. And that we can make that purchasing go into like our transaction fees in Nexus and maybe go back to embassies, or it could go to like research and development and Sirius. We'll come up with those revenue models, but basically people will have to purchase, an actual slot in low Earth orbit. And then ideally getting your own propulsion system. This allows it to be unstoppable because, you can always stop a rocket, right? If anybody ever saw, there was somebody, I think a couple of years ago, she launched unlicensed satellites with unlicensed bands, and guess what they did? They went after the rocket company. Oh, okay, we got 10 sats up without getting caught. Now what? You're screwed. And rockets are considered weapons, right? As anyone seen, Kim Jong-un's shooting rockets across everything. They're weapons, right? Even if you want to put payload of a satellite on it, well, you can still put a nuke on it, or you can still put explosives on it. So they're still considered weapons. And I mean, they really themselves are kind of just like it's like strapping a bomb to your ass. Is part of my language. That's just what I say. It's a very primitive technology, but it does what we know, and we know it's reliable. And so, we will be, assessing different launch contracts in the near term if our propulsion doesn't take off. So don't think that I'm just like chasing pies in the sky and everything. I'm just looking at the long-term scenarios. And I really do believe a solid state electrical propulsion system is going to be necessary for us to really take space exploration to the next level. I want my flying car, man. Like, okay, Ernie's been like, Colin, where's my flying car? Where's my flying? So, I'm working on it. But, that also ties in with helping with the satellite launch, and it makes it so that they can't stop it. It's an unstoppable system, right? And with that being all open source, anyone can deploy these, and boom, you have satellite constellations that self-assemble, right? So that's a really important design quality of it. Like I said, on these development updates, my lab's getting set up right now. The landlord's just working on like he's redoing the garage a little bit. I donated an air conditioning unit, and so I'll have that. But yeah, so that's really cool. But yeah, that's where that is, and that's how we solve some of these different problems and model these different orbits, things like that. But before we get to that point, we'll have basic LXOS functionality. And as I said, I'm working for the routing system right now on Arduinos, just a very basic Arduino, and I've got some 433 megahertz transceivers and some GPS modules, so I can start developing a very basic system. As I said, I'm most likely speaking in Acapulco this year and doing a workshop. We might be doing some live art, which will be really cool too. Tasha's working on some really fun stuff. I won't reveal that directly. And we'll be doing a really fun workshop. But at that time, I'd also like to have something to show hardware-wise, right? I may not have something immediately present, but I'm going to be discussing with some of their team. I know they had some challenges with setting up Wi-Fi, so we might be able to set up mesh network and Jackfest, for instance, to Jackalope. If anyone's been to that, there was interest. I was talking to Alma about that. I want to get some basic demos going, right, where we can at least start forming basic mesh networks and creating hosting networks on these mesh networks. So those are things in the pipeline too. So I'm getting to that point where it's getting hardware and getting it modeled. I've gotten the operating system to boot once, but I wouldn't say it's anything special. It's just booting the microkernel. I still have to write a lot of the other components of it. So the operating system, unfortunately, has been development-wise on the back burner for a number of years since I've had to shift back into the LLL Tau since about 2021. But I'm going to be getting back to that, especially once we get more help, helping me finish the Tau. Okay, that's all the questions in Telegram. Does anyone else have any other questions? I believe you should be able to unmute yourselves. I don't have a setting where you can't. If anybody wants to say anything directly. If you have any questions too, you're welcome to post them in the main community chat. It's another possibility. Mr. Woo. Oh, Stain, you won. All right. You're gonna ask some other questions too. Cool. Let's see. Good quality. Okay, cool. Did you here? Let me do a little test. Tell me how distinct these sounds are. I want to know if the noise suppression is a problem. Can you hear that? Does that not have the sound suppression issue anymore? I just wanted to test that while we have it. Fucking loud. Okay. Is it too loud? Okay. Do you guys want me to just do a little piano outro then? And then if anyone has any questions after that, I can do a quick answer. You guys want to play in that key? Okay. All right. C sharp minor, harmonic. All right. Cool. For anyone that doesn't know, that's the key that Moonlight Sonata is written in. I don't know. This is one of my favorite keys. But we'll rock and roll.